Data Science for Spot Weld Optimization. We have Mohan with us to talk about this. Hello Mohan. What initial challenges did you encounter with the client that could be helped with our solution?
So we had already done a pilot with this particular client. So the challenges were, in this case, were more related with how do we formulate the problem. For that, we wanted to understand the existing process. Once we understood what they are doing, what kind of data is available, what kind of digital data we can use it for our use case, we started experimenting with that. They were a little uncomfortable that the geometrical data is missing, but then it was not needed for our modeling, so which we had to convince a bit. Apart from that, I think it was a good start in this project, because having already proven that the concept works in the earlier pilot.
What process did you follow during implementation?
We understood the existing process. They were doing several iterations. In each iterations, they were trying to reduce the number of spot welds one by one, though it was not as simple as that. So every iteration they will try to do it, and then we'll see, okay, number of spot welds required is more to provide the same strength to the joints. So we looked at how it is changing by changing the number of spot welds in different areas, whether their strengths, required strengths are, the targets are reducing or increasing. Then we collected some data, sample data from their existing processes or existing simulations, what they had done. Then we started applying it using our own tools. We tried to do it in step by step, showing some samples which fills the design space and measuring it for various things. In fact, our target here was noise, vibration, harshness, durability and safety. We covered all these in sequence and then we solved this.
What roadblocks for implementation did you help the client overcome?
Number of simulations they had to do, they were thinking that it will be too many, but then we assured them, saying that we'll do in an incremental way of giving them the number of samples to simulate in their existing systems. So we took a very small percentage of what they were actually doing and then built the model on that, looked at what parameters are really impacting the targets, and then we kind of focused only on those and then gave them a next set of samples. So that way we could reduce their samples by almost 60% initially, and then probably added another 10% to give the better solution. The challenge, what they were thinking, that amount of time they have to spend in providing the data was reduced to half.
What kind of benefits did the client enjoy with our solution?
First and foremost, it is like they could save about 9% spot welds for each car. That resulted in approximately $13 million for the number of cars they produce for that model. And in addition, it saved about 40% in terms of the manpower effort.
Was there anything about the implementation or the results that positively surprised you?
Definitely, we were thinking it is going to be a complex, non-linear stuff, but it resulted to be a little bit more linear. That's one part. But the second part, we ourselves couldn't believe that we were able to save. When they actually looked at the total amount of money they could save was crossing millions, and not only million, it was 13 million. So that was great.
Thank you, Mohan. Thank you for watching.